Hey guys, it's Mr. Knockme here, about to go over Unit 6, Lesson 1, Confidence Intervals for the mean with large samples. Let's get into it here, right? In this unit, we'll be studying the inferential statistics, the second major branch of statistics. We'll be using sample statistics to estimate the value of an unknown population parameter. We will be making inferences, right? So, to start this off, right, we're going to be using this thing called a point estimate, a single value estimate for a population parameter, right? It's basically when we don't know the average for our entire population, right? And a unbiased point estimate for the population mean is usually the sample mean, x bar, right? It's a nice one to look at. So let's take a look at this first example right here. A social networking website allows its users to add friends, send messages, and update their personal profiles. The following represents a random sample of the number of friends for 40 users of the website. Find a point estimate of the population mean, mu. So, for example, this 140 right here is just one person, and it's the number of friends that one person has, and this person has 140 friends, right? And they did this 40 times, and to get a nice point estimate for every single user on this social networking site, they took a sample of 40 users and just looked at their number of friends. And that's what we have here, right? And a nice point estimate would just be the average of this sample of 40 users. And I went ahead and did this for you. All you have to do is, to get the average, of course, is just add up all these numbers and divide by, in this case, 40, right? And it comes out to be a nice point estimate is 130.8, right? And the inference we're making is that maybe for the entire population, the average number of people's friends list is around 130, right? It's not exactly 130.8 because the probability of that occurring is probably 0 because no one has exactly 130.8 friends, right? What does that even mean to have 0.8 of a friend, right? So that's pretty much, a point estimate in a nutshell. Let's go ahead and take a look at the second example here. Market researchers use the number of sentences per advertisements to measure as a measure of readability for magazine advertisements. The following represents a random sample of the numbers of sentences found in 50 advertisements. Find a point estimate of the population. Same thing, right? Except this time the context that we're doing is that it's just the number of sentences per advertisement. So for example, this random one at the end here would have 20 sentences. It's a lot of sentences for an advertisement, I think. But anyways, they did the random sample of 50 advertisements, right? So it's not the entire population, it's not all of the advertisements that are out there, it's just 50 of them. And they calculated and recorded each one. We were going to go ahead and add all these together and divide by 50. We get a nice point estimate of 20.4 sentences per advertisement of this sample right here. Again, it's really hard to find out if a advertisement is going to have exactly 12.4 sentences, right? That's just an estimate, and it's not the exact amount, or even any of these amounts would come out as 12.4. We won't have a 0.4 sentence, right? All right. Hopefully, you guys are taking a look at your notes along the way, and you guys are seeing this one right here. I'm going to ask that you guys go ahead and try that on your own and put this in your notes because you are still turning your notes in for me. So please make sure you fill this out, get the answer for this one. Tell me what is your point estimate for this example of a random number of sentences in 30 magazine advertisements. So remember, you're not going to divide by, what was the last one? You're not going to divide by 50 in this case. You're going to only divide by 30 because there's only 30 examples there, okay? So go ahead and try that and fill that out in your notes, okay? I'm going to scroll down, so if you need to pause the video, and then continue on once you're done. All right. since the probability that a population mean is exactly 14.48 is 0%, therefore we need an estimate mu which lies in an interval, right? An interval estimate is an interval or range of values used to estimate a population parameter. So when we get our point estimate, right, it's really hard. It's practically impossible to have it hit that exact value, the population mean, right, the population parameter, to hit that exact one value. So what we do is we calculate an interval above and below our point estimate, right? And that's usually where we think our population parameters should fall between, okay? And we're going to talk about how that works later on, but we do this using what we call a confidence interval, right? And part of that confidence interval is to figure out what level of confidence we're looking at here, right? Is the probability that the interval estimate contains to the population parameter. That's all a level of confidence is. So for example, if the confidence level is 90%, right? Then if we do this experiment, or we do these samplings 100 times, 90% of the times, the mean should fall somewhere between the intervals that we calculate out of those 100 sampling distributions that we would do, right? But in order to do this, we need to find this thing called critical values, which will then lead us to help us find our margin of error. But one thing at a time, right? So our confident values, right, usually comes from our normal distribution, our bell-shaped curves, right? So something that has a confidence level of 90%, you guys have seen this before. We draw this nice little bell-shaped curve here, and confidence level of 90% means that we're including 90% in the middle of our bell-shaped curve, right? So I'm looking to find a cutoff here and a cutoff here, and 90% should be somewhere in the middle, right? We need to figure out what that value is. And again, we could use our pink sheet or our z-table to help us figure that out, because if I do have 90% in the middle here, what I have remaining on the outside is 10%, but it's split between the two sides out here, which means this is just going to be 5% here and 5% there, right? 5% plus 5% gives us 10%, which is the remaining leftover of that 90% that is in here, okay? So looking up 0.05 on our z-table, 0.05 needs to be looked at in the middle here. It's not a z-score. We're looking at to find our z-table. So 0.0005 is not what we want. We want 0.05. And here's 0.02, 03, 04, 05. And it looks like it's going to be between this value and this value. This is 0.0495 and 0.0505. It looks like to be exactly in the middle of this, which would be negative 1.64 or 1.65. If it's exactly in the middle, then it's going to be 1.645 is what I'm going to write down. To get my z critical for this is going to be, the positive value was 1.645, and then the negative value for the z critical is negative 1.645, right? And that's pretty much it. That's your critical value for this confidence level, okay? You can figure this out, and this will help you to later on to find your margin of error. Let's do it again for 95%. Let's do this real quick. 95% is a little bit trickier, right? We got this right here. It's going to go ahead and curve. And in the middle, it should be 95%, which leaves us with 5% remaining. But 5% remaining divided between two areas, right? This will end up splitting this to be 2.5% on both sides. That as a decimal, of course, is 0.025. And again, we'll just look this up on our z-table to figure out what the heck our critical score should be. So I'm going to go ahead and open that up. 0.025. Let's see here. That's 0.0, and right there, 0.025. Exactly, on the dot, right? 0.025 gives us a critical score of negative 1.96. 1.96. See that? Just looking at our table there. And again, the way I got the 0.025 0.025, the way I got that was looking at this level of confidence. They telling me that it's 95%, which is 0.95, leaves us with 5% remaining, and you have to split that between the two tails. Now, why do we do this? Confidence level is going to be in the middle of our point estimate, right? And we do above and below, and that's our above and below right there, that value to look up. So we have here our z critical on this one is negative 1.96, and of course positive 1.96. Okay? So that's the first step, right? So practice looking up your critical scores based off of your confidence level, okay? That is a key element that you're going to need for this problem. Now, if you open up my table on Canvas, right, which is the appendix in the back, and you go to page 16, you might have saw it at the very beginning when I had this thing open. You might look down here at the bottom here. It actually says it right there, critical values, right? Critical values, and it even draws the picture out for you, and it tells you what your z critical, positive and negative, should be if it's symmetric. And take a look here. If you have a confidence level of 90%, right, the z-score was 1.645. Huh? It's almost like I planned this, that this should work out to be the same. The other one was 95%, and you got a z-score of 1.96. Again, huh? I didn't really have to do this work, did I? Or look at the table. They had a shortcut there for me, didn't they? Say, knock me, why did you waste my time? And I'll say, well, it's kind of fun wasting your time. But also, sometimes you don't have all of these as your given confidence levels. This is for 80%, 90%, 95, and 99%. This is all well and good, and this is the most common ones, of course. But what happens if you come across a problem where they ask something like this, where they say find the confidence level of 98%? You see how that is not on that shortcut for you, right? You're gonna have to look that one up by hand. And I really suggest that you practice doing this one and seeing what you get when you look up the value and what it splits to, okay? So that's for you to try. 99% is on there on the cheat sheet as well, so you can just go ahead and write that down. The z-score for 99% is 2.575, right? That's what I'll write down, 2.575. My z-critical, 2.575, and my z-critical for the negative side would be negative 2.575. All right, so please go ahead, write those down. Get that into your notes, and also how to set it up as well, okay? Okay, and that's that. Moving on, right? This is a concept here. Sampling error is the difference between your point estimate and the actual population parameter value, right? The sampling error is just the difference between the two. What you got for your point estimate minus the population parameter. The one thing is, though, we never really know what this is because we generally don't know what the population parameter is, right? We talked about this. It's really hard to sample, or to take data in for millions of people, right? That's usually the population that you're looking at. And we generally don't know that. And also, our data is going to vary from sample to sample, right? It's going to vary from sample to sample. If I sample 30 people here, it won't give me the same point estimate as my sample of 30 people over there. And I just realized I'm hand gesturing in this video, and you can't actually see this, but you know, left side, right side. Hopefully you guys will picture that in your mind. Margin of error. This is where we actually get into that whole idea of like, oh, plus or minus and this margin of error, right? You might have heard that saying somewhere, it's going to be an estimate of this plus or minus 5, right? It shouldn't be more than this or less than that. Well, there's actually a way to calculate this using statistics to help us to get a nice way that we'll be confident that it should be between these particular values if I do this enough times, right? Let's see here. Margin of error, given a level of confidence C, the margin of error E is the greatest possible distance between the point estimate and the value of the parameter it is estimating, sometimes called the maximum error of estimate or error tolerance. E is simply going to be equal to your z critical, which is something that we looked up or found out how to look up earlier in this video, and then times the standard deviation divided by the square root of n, right? Of course, just like our population parameter, we most times won't really know the population standard deviation. Sometimes we will, sometimes we won't, right? In the problems that we're going to be doing in the book. Most of the times in the real world, we won't know it, right? If that's the case where we don't know it, we can use the sample standard deviation, right? The sample standard deviation. But this is only allowed if your sample size is greater than or equal to 30. Again, that's just a loose rule. Generally, you want your sample size to be as big as possible, like to make it cost efficient, right? You don't want it to be in the billions, but you just don't want it to be like it's too small, okay? All right. So how do we take this and apply this all to our problem? Well, let's take a look here. This is the equation that we're going to be using to calculate our confidence interval. Simply, what we're stating is that the population parameter is somewhere between our sample statistic plus or minus our margin of error. So we're going to calculate our margin of error first, and then calculate our point estimate, and we simply just add and subtract to it, right? Plus the value, minus the value, and that should give us our interval that our population parameter should lie between, okay? So let's go ahead and take a look down here. I'm going to keep this equation up here so we can take a look at it while we're working on it here. Sorry, here, give me a second, and move that right there. Using the social networking website data and a 95% confidence level to find the margin of error for the mean number of friends for all users on the website. Assume the sample standard deviation is about 53, then construct a 95% confidence interval for the mean number of friends for all users of the website. Okay, so back on the first example at the very beginning, right, the social networking website had a point estimate, let me scroll back up there and take a look, had a point estimate of 130.8. Let me go back down, 130.8. So let's write that down. Our point estimate was equal to 130.8, okay? They've given us some more information here. We know that C is 95%, and we know the sample standard deviation is equal to 53. All right? They want us to construct a confidence interval with the mean number of friends for all users on the website. So it's basically we're going to be following this guy right here. Okay? We're just going to be plugging in our point estimate here, and we're simply going to be adding and subtracting our margin of error. And our margin of error is just this equation over here, this guy. Very simple equation. We are going to need our standard deviation. We only have the sample standard deviation. That's going to go in here, right? We do have our n. That was at the beginning of the problem. That told us, they told us how many people did they sample. I already forgot it. I'm going to scroll back up. Sorry if you get dizzy with me going back up and down here. I should write this down. Sample was 40 users, so my n in this case will be 40 for this problem. And the last thing that we're going to need is our z critical. Our z critical, which is this guy right here. Our z critical will be based off of our confidence level, right? Confidence level of 95%. We found out that that critical score is going to be 1.96 and negative 1.96. I'm just going to write down the positive one, 1.96, because we are going to end up adding and subtracting it anyways. The plus or minus is just to help you along that. One less thing to memorize. Anyways, let's go ahead and calculate this. So I have my point estimate here. Let's go ahead and calculate our margin of error. Our margin of error is simply going to be equal to my z critical, which is, in this case, 1.96, right? Multiplied with our standard deviation, but I'm going to be substituting 53 in, right? 53 in for our standard deviation of our sample, because our sample size is greater than or equal to 30, and I can't do that, right? I don't know the population standard deviation, and that's okay in this problem. And I'm going to go ahead and divide by the square root of 40, right? The square root of 40. This will help me calculate my margin of error. So this is going to be equal to 1.96. Let's open up my calculator here. It's going to be equal to 1.96 times, I'm going to put this in parentheses to make sure that I don't have any dividing problems or order of operation issues here. It's going to be 53 divided by the square root of 40. Oh, hello. Square root of 40. There we go. And this will give me a margin of error of about 16.4249. I'm going to round that to about 14.42. About 14.42. Okay? So that's going to be our margin of error that we add and subtract to our x value. So our mean, let's scroll this up a little bit here. So our mean simply needs to lie between that, right? Our mean is going to be less than 130.8 plus 14.42, and of course it's going to be greater than 130.8 minus 14.42. That's it. That's all I'm doing. See, this is my point estimate minus my margin of error, and this is my point estimate plus my margin of error. And that's it. That's how we get our interval, right? We just simply do the sum and the subtraction here real quick. So 130.8 minus 14.42, right? That's going to give me 116.38. That's what my mu should be between, or be above, be greater than, and my mu should be less than, whoops, get out of there, 130.8 plus 14.42, which will give me 145.22. 145.22. And that's it. That's what your margin of error needs to be between. And that's how you calculate your confidence interval. Okay? I'm going to go ahead and have you guys try this example right here. I will put it up onto Canvas as well for you to type in your value. You're not going to submit your notes just yet after this video ends. I'm going to end this right here after you try this example and, you know what, this example as well. Okay? So if you guys could, it'll be first magazine advertisements of the first U-Try, which was this one up here, where the x bar was equal to 14.2. That's going to be this one right here. And then if you have that one figured out, I want you to calculate the confidence interval for this one as well for the U-Try. And you can do these using your calculator, of course, to calculate it. And just a small disclaimer, right? We're going to skip those for right now. Just a small disclaimer. Interpreting this result. When you get those answers, when you get the interval of, let's say, 22.3 to 23.5, right, with a 90% confidence interval, this is the wrong way of thinking about it, by the way. This is not saying that there is a 90% probability that the actual mean is between 22.3 and 23.5. What is actually happening is, if a large number of samples is collected and a confidence interval is created for each sample, approximately 90% of those intervals will contain mu. So that means that if I did this 100 times, I got a confidence interval from here to here, I got another confidence interval from here to here, another confidence interval from here to here, and I did this, like I said, 100 times, right? About 90% of them would contain the mean. About 90% of them, about 90 of them out of 100 would contain the actual mean of the population. Okay? So again, I'm going to end this video here. This is part one. Don't submit your notes after just watching this video. Just submit the problem for this U-Try and this second U-Try into Canvas. And then once you finish with that, I'll have the second part of this video up, and hopefully we'll finish up the notes then, and you can go ahead and submit the notes after, okay? Okay. Have fun with that. I'll see you guys in the next video. So long.